You want to pay the front. Good morning, everybody. Today we're going to work with density. So our objective is that you're going to use the appropriate tools for measuring volume and mass to gather data in order to calculate the densities of certain substances. So in front of you, each of you should have a worksheet. Is that right?
Yes.
Okay, you should also have a bucket, a container of water, and you should have 3 different types of fruit. So we're going to start with our engagement. The fruit you should have is a grapefruit, a banana, and a grape. So what I want you to do is I would like for you to first predict which of those 3 types of fruit do you think is going to sink or float. So thank you. Can somebody share with the class what their prediction was and what actually happened? James.
My prediction for the banana will float, and it floated, and my prediction will float.
Okay. What about the grapefruit? Fonta?
My prediction was it was going to sing, but it actually floated.
Okay, and the grape? Yes, Sharon?
I thought it would float, but then it was.
Okay, question. Why did we, raise your hand if you thought that the grapefruit was going to sink. Okay, so those of us who thought the grapefruit was going to sink, why did you think that? Somebody tell me why, Terrell?
Because it was heavier.
Because it's heavier? Yes?
Well, yeah, because it was heavier, because I saw a movie where a bigger object sank to the bottom of the ocean.
Okay, Stephanie?
It has more mass.
It has more mass. Well, we'll see eventually if it has more mass or not. What about the grape? What about the grape? Raise your hand if you thought the grape was going to float. Okay, most of us. Now, Cindy, tell me why.
Because it has less mass.
Because, but did you measure the mass?
No.
Same thing. Okay, did you measure the mass? So we can't go by the mass. We can't go by something that we've actually observed. Alexis,
It had less weight.
did you measure the weight?
It looks smaller.
It looks smaller. Okay, so how many people agree with Alexis? We thought that the grape was going to float because it was smaller. Okay, put your hands down. Now this is a misconception that a lot of people think. They think just because something is bigger, it's going to sink, and just because it's smaller, it's going to float. But really, what we're looking at is something called density. Okay? Density is a relationship between mass and volume, something that we should know about already. So before we really get into density, let's just do a quick turn and talk. I want you to turn to the person next to you, and you're going to take about a minute or 2 to talk about what you know about mass and what do you know about volume. You ready?
Yes.
Okay, let's go.
Greater objects. Greater objects will float away. I mean, no, sink. And
We'll question and help her out. Is mass and weight the same?
no.
No? So what is weight, Sharon?
Weight is the measure of gravitational force.
The measure of what?
Gravity.
The measure of gravity. And mass is the measure of gravity too?
No.
So what is it, Emma?
Mass is the how much space it takes up. It's like a matter, like
Okay, I heard the word matter, so that's part of it. So mass is how much?
matter is in an object.
Matter, thank you. Matter is in an object. And volume is how much space it takes up. Now we also said that mass and weight were not the same because weight does what?
Changes due to location.
It changes due to location. If I go somewhere that has less gravity, then I'm going to weigh less. If I go somewhere that has more gravity, then I'm going to weigh more. What do we measure mass in? What is the SI units for mass? Jacob, you know?
Square meters.
Square meters?
That's different.
Well, meters is definitely distance. Remember, we use our triple beam values. It's right in front of you.
Wait, what's this one? Square kilograms.
Where are you getting the square from? I think you're mixing volume up, which is cubic centimeters. and mass. Somebody tell us. Somebody help Jacob out. Stephanie?
Kilograms and grams.
Kilograms or grams. Now, volume is measured in either milliliters or cubic centimeters, which is cm cubed. Moving on. In our experiment, any fruit that floated has a density, and I'll put that word up here, a density that's greater. Any fruit that floated has a density that is less than water, and any fruit that sinks has a density that's more than water. The density of water is actually 1 gram per milliliter. So based on this information, we know that the grapefruit and the banana had a density that was less than this, right? And the grape had a density that was more. Let's go back to the misconception that bigger items will sink and smaller items will float. Now, density, I said, was a relationship between mass and volume. So density equals mass divided by volume. And there's a very easy way for us to remember this formula. What do we call the area where we live? What's the nickname for the D.C., Maryland, and Virginia area?
Prince George
The
County.
DMV. D.C., Maryland, and Virginia. DMV, right? Well, this here is the science version of the DMV. So instead of D.C., Maryland, and Virginia, it is density equals mass divided by volume. You see it? DMV. Now going with our units, mass is measured in grams, volume is measured in milliliters or cubic centimeters. So my density is measured in grams per milliliter, or I can say grams per centimeter cubed, because this is the volume as well. That per there would be my division, because I divided.
Centimeters cubed the same thing as milliliters?
Yes, it is. 1 milliliter equals 1 centimeter cubed. Same thing, exact same thing. Now we're going to do some explicit instruction right quick on how to read a problem and how to take the information from that problem to calculate the density. Give me a second. So what I'll do is I'm going to walk through how I think about a problem when I problem solve. And your job is just to listen to me and watch, and you can jot down notes as I go along so that you know how you should flow through the problem, okay? So, first I read the problem. A small block of wood floats on water. It has a mass of 200 grams and a volume of 250 centimeters cubed. What is the density of the wood? So the first thing I got to do is I have to think about what are they asking me to find. And in this problem, they're asking me to find the density. What is the density of the wood? Then I got to look at what they gave me, given. They already gave me the mass. The problem says that the mass of the wood is 200 grams. And they also gave me the volume. Says the volume of the wood is 250 centimeters cubed. So, since I have the mass and I have the volume, I can go ahead and I can use the formula that I know. Density equals mass divided by volume. And then I can plug in the data that they gave me. Mass is 200 grams. Volume is 250 centimeters cubed. After I plug in the numbers, I can do a simple division problem and get the answer to this problem solving question. So 200 grams divided by 250 centimeters cubed would actually give me 8/10. gram per centimeter cube. I know that because I just divided. Any questions so far about how I found out what they were asking for or how I knew to plug in the formula? Any questions? Okay, good. Let's look at the we do. It's on your worksheet. And let me change over here for that. Can I get a reader? Stephanie?
A sample of liquid has a mass of 24 grams and a volume of 16 milliliters.
Yes, 16 milliliters.
What is the density of the liquid?
Okay, so in this portion of the explicit instruction, we're going to do this together. So, somebody tell me, what are they asking for me to find? James?
They're asking you to find the density.
They want us to find the density. Can someone tell me what they gave us to help us find the density? Terrell?
A mass of 24 grams and a volume of 16 milliliters.
Okay, so mass equals 24 grams. And the volume is 16 milliliters. So what am I to do next? I need to get my love.
We divide the mass by the volume.
Okay, so I'm going to use the formula for density. And my love, I said density equals what?
Mass divided by volume.
Mass divided by volume. So now that we know the formula, we're going to go ahead and do what, class?
Divide
We're going to divide what?
24 grams divided by 16.
20. When you guys are completing the division, don't forget your units. Don't forget the units for mass and for density. You want to put them every time. Okay, can I have everybody's attention in 3, 2, 1? Look up, please, Jacob. Thank you. Can somebody share with me what their answer was? Sponsor. Thank you. So 2.9 grams per centimeters cubed. Raise your hand if you had that answer. All right, most of us. So, keeping with the objective, now that we know what density is, and we know the formula for calculating density, what we want to do is we're going to use our triple beam balance to measure the mass of objects, and we're going to use a ruler in the formula length times width, volume equals length times width times height to measure the volume. So once you get the mass of the object and the volume of the object, we're going to use the formula density equals mass divided by volume to calculate the density. So you can put your buckets to the side. I'll come get those in a second. But in your baskets, you all should have 3 math manipulatives. You should have rulers. You should have triple balance things. And on the back of your paper are directions, what I pretty much just said, and there's a table for you to complete as you're conducting the hands-on activity. Any questions? So what are we doing here?
Finding the density of the
One
object.
person, please. Jacob?
Finding the density of the object and completing the table.
Okay, we are finding the density of the object and completing the table. How are we going to get our mass?
Using the triple beam balance.
Thank you. And how are we going to get our volume?
Multiply length times width by using the ruler.
Okay, we're going to measure and then we're going to use the formula for volume. Okay, let's go ahead and get started. Your work is through.
I use the triple beam.
So we're missing. Look at the mass, color block.
Maybe another color.
Volume is 3 divided by 5 so 4.
Is it going with those? Keep going.
No.
5.4. Go back. So sometimes it's good when you do
4 divided by 3. 1.8. 1.81 grams per centimeter cubed.
Would this be the same thing?
Okay.
The 100 is equal to, oh, yes.
Okay, let's go. Let's do this.
You all are working on the density of the 100 feet.
No, I'm still getting it.
Okay, so this here is the 10 species now.
Can I get everybody's attention in 3, 2, 1, ladies? Thank you. We're gonna move on. Can somebody tell me how you got the density of the colored block? Yes?
Well, first we had to find the mass using the triple beam balance,
And it was?
and the mass was 3 grams.
Okay.
And then we found the volume. We found the volume by using the ruler and getting the length, the width, and the height. And we multiplied those together to get 8 milliliters, and then we divided 3 by 8.
8 milliliters, go back, 8 millimeters.
8 milliliters.
But did you measure in milliliters? In order to measure in milliliters, you have to do water displacement. Did we use water for this? We measured in
Centimeters.
centimeters. So after we multiply our length, our width, and our height for the colored block, our volume was
8.
8.
8 centimeters cubed.
Thank you. And what's your density? And how did you get your density? And what is it?
We divided 3 by 8, but we rounded.
Okay.
So we got 0.38 grams per milliliters. 0.338.
So 38 hundredths grams per milliliters was your density.
Yeah, we
Class.
rounded.
Oh, sorry. Based on Jacob's group's density of the color block, 38 hundredths grams per centimeters cubed, excuse me, would his block sink or float? It would sink?
Should we test it there?
No, we're not going to test the theory. Think about, you said do what? Okay, raise your hand if you think it would sink. Remember the density of water is 1. Is his density more or less than the density of water? Less. So is it going to sink? Raise your hand. Is it going to float? Now somebody who said it will float, tell me why, yes? Louder, Sharon. Okay, so she said that 3,800 is less than 3,800 gram per centimeter cubed is less than 1 gram per centimeter cubed. If it's less, then it's going to do what? Float. If it's greater, then it's going to sink. Quick exit ticket. Everybody grab your true and false cards. We'll just go through 2 questions. That's it. So when I give you the question, if you think it's true, put true. If you think it's false, you put false. Number 1. Density is how much space an object takes up. True or false? Okay, now, Stephanie, who put false? Why did you put false? Because the volume is how much space an object takes up. Density is actually the relationship between mass and volume. Okay. Number 2. Density equals mass times volume. True or false? Okay, I see mostly falses, but I do see a true. Somebody who said the answer here is false. Now somebody tell me, what does density actually equal? Jacob?
Mass divided by volume.
Mass divided by volume. Last question. If an object has a density of 5/10 grams per milliliter, it will float. True or false? Which is that, Terrell? True or false? What do you have up? True. Cindy, what do you think? Sorry. Thank you. The answer here is true. Remember, if it's less than the density of water, which is 1 gram per milliliter, then it's going to float. If it's more than the density of water, it's going to sink. sink. Well, we'll stop right here